Hey dude, this is Mr. Post, and on tonight's video, we're going to be looking at solving for the pH, the pOH, the H plus ion, and also the OH minus ion concentration. So we'll be looking at two examples of solving these problems tonight. Just a little background for you. Whenever I reference the H plus, I'm also meaning H3O plus ion, the hydronium ion. Alright, so they're kind of interchangeable. So just understand whenever I mention H plus, I'm also mentioning the H3O plus ion. And this is concentration, and the concentration is measured in molarity. And that goes for my hydroxide. Hydroxide is my OH minus. It's associated with bases. When I multiply the previous two, the H plus and the OH minus concentration, I always end up with 1 times 10 to the negative 14th. That's a given, and it's going to be important because we can always use that number in order to solve for either the H plus or the OH minus. And the last relationship I want to look at is when we look at the strengths of acids and bases, we typically measure them, the acidity or basicity of the solution with a pH scale. We could also use the pOH scale, which we learned recently, but when I add up my pH plus my pOH, I always equal 14. So just a little background before we get into the problem here. So we're looking at two problems tonight. Problem number one asks us to calculate the pH, the pOH, the H plus, the OH minus concentration of a sodium hydroxide solution, and the sodium hydroxide solution has a molarity of 4 times 10 to the negative third. Kind of important for you guys is the formulas we'll be using tonight are the ones right there. Now, just so you know, there are more than one way for you to get to the correct answer. Okay, there's more than one method that you can use to get to the final result, which is kind of cool. So although I'm presenting one way, just know that if you see a different way to get there, you're probably right, especially if you're getting the same answers. Now the first thing I'm going to do is take from the problem. My problem gives me, I have a sodium hydroxide solution, and it has a molarity of 4 times 10 to the negative third. So that means my OH minus concentration is 4 times 10 to the negative third. Now I'm doing that because when OH, which is right over here, is going to hit the water, it's going to dissociate. Dissociate means breaks up. And so the Na is going to be split from the OH. And you're going to have 4 times 10 to the negative third ions of hydroxide OH. So that's where I got that from. And so what I've done is I've solved for the OH, or the hydroxide concentration. So that's one of the 4 things is taken care of. And I didn't even need a formula to do that. Alright dudes, next up we have the pOH. Now you could have gone a different route actually. You could have solved for the H plus using that formula right down there. I'm just going to go straight and calculate the pOH. And for the pOH, I'm grabbing the formula right there. pOH is a negative log of the OH ion concentration. And when we start doing the substitutions in here, I just substituted right here the ion's concentration from the previous step. And when I do that, I find I have the pOH of 2.40. Awesome, dude. So right now, I've also now taken care of the pOH. Where do you want to go next? Well, we have to now solve for the pH and still the H plus ion concentration. The place I'm going next is to solve for the pH. And I'm going to use this formula right here. And the pH equals 14 minus the pOH. I just did a little rearrangement of it. When I do my substitution, the pH is 14 minus 2.4, and the pH is going to be equal to 11.6. Alright, dude, so my pH is taken care of, and the last thing I'm going to do is now solve for the concentration of the hydrogen ion. Now, the one formula I did forget to put over here on the right-hand side was this formula right here. I see I kind of doubled up on a formula in retrospect, but we're going to use this formula here. It's kind of called the inverse log, where I'm going to use 10 to the x equals the H plus ion concentration. Now, I'm going to do a little substitution. Instead of x, I'm going to use 10 to the negative pH. When I throw my substitution in there, I'm using this from the previous step, so 10 to the negative 11.6 is going to be equal to my hydrogen ion concentration, and that's going to be 2.51 times 10 to the negative 12th. Now, what do we got here, guys? Something that has a pOH that's kind of low means the solution is basic. So I have a low pOH. This means I have a basic solution. That's supported by the fact that my pH is actually 11.6, which is definitely a basic solution. The other thing I would look at here is that the hydrogen ion concentration has an exponent value of -12. That means the pH of it is probably going to be somewhere a little below that in the 11 range, and I'm supporting that with a pH of 11.6. Now, I do want to show you something else. We were solving for the hydrogen ion concentration. You know, we do have this relationship here, the H plus and the OH minus. When I multiply them together, I get 1 times 10 to the negative 14th. When I rearrange this equation, I could have done the H plus ion is going to be equal to 1 times 10 to the negative 14th divided by the hydroxide, and the hydroxide ion was up there. I'll use that 4 times 10 to the negative 3, and likewise, you still would have ended up with an H ion concentration of 2.51 times 10 to the negative 12. So there are more than one way to do this. Just a little reference for you guys. When I am mentioning the log, I am mentioning this button right there on my calculator. Your calculator should look somewhat similar. You know, it's not going to look exactly the same, but you should have a log button. Generally, when I'm solving for this right here, the 10 to the negative x, or I use the 10 to the negative pH, I'm actually going the shift button. Alright, so that's right, I need to press the shift button and then the log to get to that right there. And that's what I'm substituting in. Another important thing, when you're trying to press these negatives, you're not pressing the minus button. Typically on these calculators, you should find a negative button, and I have that right down there on mine. The last thing that's going to be important for you with your calculator is going to be using this button right here, EXP. Now, when I enter in this number, 1 times 10 to the negative 14th, in the calculator, I enter 1. I enter in mine the EXP button. Now, EXP means times 10. I would follow it up with negative 14. So just so you know, the EXP button can also be expressed on some calculators as the EE button, and also recently something like that, or maybe it's X times 10 to the N. One of those. Alright, so all of those mean the same thing, and they mean times 10. So please be familiar with your calculator. Alright, dudes, let's go on to the last problem. What I'd like you to do, if you could, is try the problem on your own. Okay, just try it on your own. You got nothing to lose. I'm going to show you what we're going for. In this problem, we're going for three items. We're going to solve for the pOH, the H ion concentration, the hydroxide ion concentration, but I'm giving you now an HCl solution that has a pH of 3.2. So different than last time. Last time I gave you the concentration, a base solution. This time I'm giving you a pH. And I'm asking you to give me all the rest of the stuff. So right now, just bear in mind, what have you been given? You've been given the pH. And so from the pH, you could easily snag the H plus ion concentration. You've also been given the pH. So from that, you can grab the OH, the pOH. You know, from the pH, once you grab the H plus, you can then sub it into there. You know, my point is there's a lot of ways you can go. So let's just go what I did here. First thing I did, I wanted to find, with the pH of 3.2, I wanted to find out what the H plus ion concentration was. And so I'm going to use 10 to the x equals H plus. Once again, that's the formula that I kind of forgot to put down over there. And I'm going to be using that button right there. And so 10 to the negative pH instead of 10 to the x, and I'm going to use 10 to the negative 3.2. Once I do that, I find out, I have a little typo here, that the H plus ion concentration, I was short of 0. It should have been 0.12363 molar. Should have been the hydrogen ion concentration. It looked a little off to me. Next, I'm also going to calculate the pOH, because if I know the pH in this case is going to be 3.2, and I know 3.2 plus pOH equals 14. When I rearrange the problem, the pOH equals 14 minus 3.2 now, and I can solve for the pOH. The pOH is 10.8. Last thing I'm going to do is use my pOH and plug it into the inverse log function, and I'll solve for the OH. So as I do this, and my little substitution of 10.8, I'm going to solve and find out that my OH concentration is 1.58 times 10 to the negative 11th. And that kind of wraps it up, guys. That kind of wraps it up. The one thing I would caution you about is, once again, just using your calculator. I find that's going to be probably the number one problem students are going to have is learning how to use that calculator. Once you got that calculator wired, the rest of this should be golden for you. All right, dudes. Thanks a lot for tuning in. I truly hope it was helpful. Have a great day. Peace.